Hi all. Today we are going to discuss all about single linked list. It is also called as one-way linked list. And let's discuss what it is, how we can create it, and how we can normalize it in the form of Python code. So, as we can see here, single linked list or a one-way linked list is simply a collection of nodes. It is a data structure, and let's call it as a linear data structure. Since whatever number of nodes we are going to maintain in a linked list are in the linear form, they have this sequential structure that they follow, and that is why it will be called as a linear data structure. Also, whenever we are saying that it has collection of nodes, each node will contain two things, two parts. First is data, that is the value that we are going to maintain. It can be of any data type. We can maintain an integer value or decimal float value, or we can maintain character string or any Boolean value, anything. And the second part of the node will contain address or reference of the next node. So this linked list creates a format where each node is connected to the next node. And that is why it is a one-way linked list, or it can be also called as single linked list. How we can identify the last node is simply that the node that points to a null value, or technically in Python, it will be also called as a none value, will be called as the last node. Now, when I'm saying that we have to identify the last node as such, it means that it does not have any index concept. So we will not be able to access the contents of linked list through its index, just like we do in list. But to access the linked list content, we will need to perform traverse operation. We have to visit each and every node to get through the entire linked list. So we will be discussing operations on linked list. But before that, let's discuss how it can be formed easily, how we can form a certain linked list without writing any functions or just making it too complex. So let's just go to the basic part first, and then we will make it through operations. So let's discuss all about single linked list. So the first thing I'll be doing is I'll be simply creating this example linked list. It has three nodes, one, two, three, and the last node pointing to none. So to create this, I am simply writing that I want to create first a node reference. For that, I'm creating a node class. This node class will have an init function. This init function will help me to get a data for my node. And in this, I will initialize data for the node with the data passed. I will initialize the next node, the next node to be none. Now, initially, I'm saying this next reference is none, as initially we are not knowing which node will be appearing after the current node. And that is why the initial default value will be none. We will be updating this value gradually once we will start creating this linked list. So let's start creating this simple linked list. So I have simply created a node, and now we will create this 1, 2, 3 linked list. So for that, I will create a first object of my node, let's say N1. And for that, I will write N1, and then I'm calling my class, which is node class. In node class, I'm passing a data 1. So by doing this, I have created one node in my memory. It has data as 1 and next as none. Now I have to set its next, but I do not have any other node created. So let's create one more node. So I'm creating one more node here with value 2. Similarly, I'm creating a third node as well, which is value 3. Now I have three nodes in my list, but they are not linked to each other. So our main concern is whenever I'm talking about linked list, mainly the thing that I need to focus on is connecting all of them. So how we can connect? We can make it very simple. I will write N1 dot next equal to n2. What will happen by writing this statement? It is very simple to understand. What I'm saying is the next node of n1 should be n2. After this, I'm saying n2 dot next will be n3. And since I'm not writing anything for n3, by default, the value we have initialized for n3 will be will remain none. So I don't need to write anything for n3 as such, or we can explicitly mention it again if we want to. But as I said, by default, the value set to none, and that is why it is not necessary to rewrite the same thing. Now I need to simply print my list. So I will print n1 dot data. For now, we are not forming any head node or anything else. So I'm just printing each data from my node. So I'll just put it like this. I'm just putting some arrows in between n2 dot data, n3 dot data, and that's it. I can further write it as that it is further pointing to none, just to make it look like what I gave it in the example. So none as cannot be directly, we will be printing as such. So I'm just writing it. Just to form this example, I'll just save all of this and let's run it. So as we can clearly see the output that we expected, that it has three nodes, 1, 2, 3, and the final node is pointing to none. Now, obviously, you will think about how this next is happening. And here, when I'm printing the data, I'm simply calling the data part. There is no next reference, or we cannot be sure about they are all linked. So for that, we will be creating some functions, some operations in this linked list. But till then, I hope that you have understood this particular part well, where we have created a linked list in very basic form. There are no functions, nothing. Just one class with just one definition, and just we are creating a linked list with the help of it. Nothing else is needed. Now, let's move on to an further level of working on the operations of singly linked list. And for that, I will just make some changes in the same code. So for that, I'm adding one more class to this, and I'm calling this class as singly linked list. We can name it as anything else, but I think this will be more meaningful name. Inside this, I'm creating another init function for this particular class. What I want to initialize will be a head node. Now, this is something that we have not discussed yet. So I will tell you what is head node. So by adding it to the comment, I'll simply write head node is the first node of the linked list. As I have already mentioned that there is no index concept in the linked list. So there is no particular way to identify which node is first, which node is last, which node has which position. There is no such thing. In such a case, there must be some identification for this thing. So now we will add some of the more functions. And as we talked about the head node, it will be simply the first node of the linked list. So moving on to referring to the first node, initially, again, we are setting it to none as we are not sure about which node will be the first node. You can see below that I have created three nodes, but I have not yet decided which node is the head node of my linked list. So we can do that change later on in our code, saying that this particular node is the head node. So for now, let's go with the next thing. So I have the head node initialized to none. And now I am adding one function called traverse. This traverse will help us to work on the part where I said that each node is related or linked to the next node, and we will be able to analyze this particular thing through this function. So let's see how to work with it. The meaning of traverse is to visit each and every node of the linked list. So how we can do that? For that, I will start with the head node. That is the first node of my list. So whichever node that will be. So I will create one node, let's say T, and I will store head node into it. Now I will check if T exists. So until and unless T is not none, I will continue with the loop. So unless and until T exists, the loop will continue. And what I will be doing inside loop is I will be printing each and every data from my node. So what T will be referring to? T will be representing each node in my linked list, and data part will be fetched from that each node. In this thing, I can add arrow as well, just to, present it in similar to the linked list that I gave in the example. Or I can simply just print all the values. That is also fine. So now after doing this, I'm just printing all the values, and that is it. The data is done. Yes, the another important part to be added into this is I have to move to the next node as well. I'm not printing only current node data. I need to move to the next. And for that, I have to write T equal to T dot next. By this, the current node address will be switched to the next node, and it will keep on doing it until it goes to a none value. So this will keep on going. And now let's change this last statement. So instead of going to print, I will simply call traverse function from the singly linked list class. So how we can do it? So again, I am here creating an object of singly linked list S. It does not have any parameter. As you can see, the init function in singly linked list only has a self reference, that is object reference. Self is here, will be S. So I do not need to pass any parameter. Further, I need to decide the head node. So what I'll do is I'll write S dot head equal to N1. So I have decided my head node, and the head node currently I have referred to is N1. And now I will simply say S dot traverse. Now let's see what will be the output of this particular part. I will run this code, and you can see that we are getting the values in sequence as we have created them. Now, how 1, 2, 3 is coming, even if I'm not printing it explicitly, why it is coming? Because we have called the traverse function. How it is starting with 1? Because my head node is N1 and N1 has value 1. How it is moving to 2 and 3 as well? Why only 1 is not getting printed? Why 2 and 3 are also printed? Because they are all connected. And you can see that here in these two statements that N1 next is N2 and N2's next is N3. And by default, N3's next will remain none. So by this logic, we have connected all the nodes and we can clearly see the results through traverse function. So this is one of the operations. Moving on to another operation. Let's suppose instead of putting values like this, I want to accept all the values from user and adding them to the linked list through function automatically. So for that, I will need another function. We can do two types of insert operations. Either we can prepend, as in we can add a value at the beginning of the list, or we can append, that is, we can add values at the end of the list. So let's do append. That will be more useful right now. So for appending, I will say that since append is already a keyword, we will say add at the end. Add at end function I have created, suppose. And what value we need to add. So that will be given through data, or we can put it as val or any other variable. The first thing we will be doing is creating the object because data is just a single value. I have to convert it into a node so that we can insert it. For that reason, I am creating it as n equal to node, and inside node we are passing data. So we have created a new node, okay, with the given data. Now this node has to go inside the linked list. So for that, we need to check two things. First, whether the head node is there, as in whether list has at least one value. Because if head node is there, that means there is one value present in my linked list, at least. So if head node is there, I need to go through the entire list and I need to go to the end of the list and add this new node. If head node is not there, it means that my list is empty. So agar list empty hai, I need to simply put my node into the list and make it a head node. So let's check if self.head is present. If it is present, there is a different condition. If it is not there, then there is a different thing. So if it is present, I need to traverse my list, right? I need to go to the end of my list. So for that, I'm creating this temporary node, and inside that, I am storing this head node, and I will simply go to the end of the list. So while t, as until t becomes a none value, I will just keep on moving to the next node. So it will just keep on moving to the next node. And finally, uh, in once the loop closes, T should be having the last node present inside it, right? So now what I have to do with that particular node? So I will be adding my current node to the next of T. Now we need to first check whether we will get the last node value here. The problem with this is the loop will stop when the value of t will be none. So we cannot say the next of none will be my new data. So we need to make some changes to this condition. My condition here will be, sorry, as I was adding this as a pointer, I will be writing it as while v dot next. By this logic, what will happen? It will check if the next node of the t is not a null value. Once we will get the next node of the t to be null, it will stop. And by that logic, we will get our last node in t. So I will say t dot next equal to my new node, right? And n will that new node will by default point to null or a none value. I don't need to explicitly write it. So I will simply go to the else part. So if the head node is not there, okay, meaning that the list is empty. So if the list is empty, the new node will become the head node. So this is quite a simple thing to add. And that's it. My values are added by this particular logic. Now, how to put it here? So for this thing, the linking is also done in my insert function or add at the end function. I have also done the linking of one node to the next node. Also, I have added the values to the list. So both the things are achieved through this function. Now, how we will deal with it? So also head node is achieved. So you can see that entire part I can remove. Everything that I did in my basic code where I created some three objects, then I created next link, and then I declared the head value. So all that part now I can remove just because of creation of this one function. So it will help me to reduce all that part. And this has now extended it to the length where I can add any number of values. So I can simply put a loop and add any number of values to my list. Let's see how. So I will tell the user to enter 5 numbers, and all these 5 numbers have to go into the link list. So I will just create a loop which will go in the range of 5. And inside this loop, I will take each value. So let's say it is coming as A, suppose. So A will be int input. I don't need to pass any further message inside input as I have already given a prompt at the top. So A will be having each value accepted from the user. And now that A has to be inserted into my linked list. So I've already created the object S. I will simply write S dot insert, sorry, S dot add at end. And in that I will pass A, where A is the data that I want to put into each node. So every time whatever value user is giving will be inserted into my linked list. Head node will be the first value that we have passed. And that's it. We will get all the 5 values in the linked list. And through traverse function, we will be able to print the entire linked list. Let's see how to get this output. So I'm running this code and let's see how it will work. Let's delete this terminal and run our program again. So we will get one clean execution. So again, I'm entering here some 5 numbers, let's say 1, 2, 3, 4, and 5. And you can see that these values are printed. Let's give it a title just to recognize or just to give an understanding to the user that these are the values from linked list. So I'm adding one print statement telling that linked list values are. So just to be specific, we can print them on the same row. So just to again give a look and feel of a list. So what I'll do is I'll add end a parameter over here and this end will have a space. So let's run this again and see what output we are getting. So same values I'm putting and you can see that the linked list values are printed on the same row and that too with a space. So that is how we can deal with these two functions. Adding these two functions have simply changed the scenario. It made my code dynamic. I can add any number of values. Uh, just made it easy for me to deal with all the data because initially I was just dealing with 3 values, so it was simple to write. But if I need to add 100 values like that, this will be the easier way to do that. I'll just create one function, call it 100 times in my loop, and the work is done. So this is how we can deal with these two specific and important functions from the single linked list. What other things we can do is we can create a search function as well to check if the certain value is present. So if I need to check that, again, I need a data to be searched. Inside this, I need to put a loop where I can go through the entire linked list. For that, I need to first check if the linked list is present or if it is empty. So if the data is there, if the head node is there, that means data is present in the list, then I'll just go through the entire list. So I'll say if C as self.head, I'll go through the entire list and I will compare my given data with T dot data. So if both are matching, I will say print. We can make it a Boolean function as well, where we can return true and false, or just give a message here itself so that we don't need to deal with it later. So here I'm just giving a message that data is found or is present. And that is it. We can break the loop here. We don't need to go further once we have got the data. If list is empty, then we will say print linked list is empty. That is it. The other part we have not handled yet, where we have to print that the data is not present only. So we can write else part to this file, that if the entire loop went till the end and still we have not got the value, then we can say put this else and print it as data is not present in this list or in the list. So this is where we can search, perform a search operation. So if I'm asking a user that, let's say, again, I am taking a suppose and telling the user to input a number to be searched. So I'm saying input, enter a number to be searched. So whatever number user enters, if it is present, it should give the message. If it is not present, that message should be also given. If the list is empty, that message also we should be able to see. So I simply need to write s dot search and inside I need to pass a. And that's it. The work will be done. Let's save this and run this. Let's clear this terminal and let's run our program once again. So it is saying enter five numbers. First, I have my list created. And now it is asking for the number to be searched. So suppose I am searching for four. Uh, okay. One thing that we have missed is adding or moving our list to the next node. So this is very important thing, that no matter what, we need to make sure that our list is moving further, or our traversing or our searching is moving further to the next node. And for that, we need to write t equal to t dot next. So this is very important part. And as we have seen that if we do not write this particular part, our output is going infinite since it will never go to the next node. So this part is very much important. Let's clear this terminal and let's run it again. So again, I'm adding some five numbers to my list. The number that I'm searching for is four, and it is saying four is present in the list. If we run it again, entering the same set of numbers, and now I'm searching for six, it is saying six is not present in the list. So both way we have got a correct output. But as I said, this part is very important where we are moving to the next node. And if we do not move, it will go infinite, leading us to the incorrect output. So that was about creating a node, adding three important functions, that is initialization of the head node, then adding data at the end, searching a particular value, and also traversing. We have performed all these important operations, covered them in this particular program. Let's do one more function and the last function from this linked list called delete. Now, delete as again is not a keyword, so we can use it. We will take the data that we want to delete from the linked list. So it will be simple to go through it. Now we have to first look for that data. Okay. And again, we have to check if the list is there. If the data is there, then only the delete is possible. So if data is there, we will move further. Again, here we will start with the head node and we need to traverse again. So till the end of the list. And we have to search for the data. So we will say that if t dot data is equal to given data, double equal to as we are comparing. So if the data matches, if we get the data that we want to delete, what we need to simply do is we need to get its previous node, okay, and then point it to the next node. So now we have to think about how we can get the previous node. Okay. So what we will do is, before doing this, if we will take one more node called T and we will initialize P with a node T. And initially, let's say P is T only. Okay. Now, before that, we have to also check if it is the first node itself. अगर first node है, so we will be deleting the head node and our next node will be the head. So that will be the another condition. So let's first cover that part. So if self dot head is there, we will say if self dot head is equal to, sorry, self dot head dot data is equal to data. So if the data is matching to the head node data, we are deleting the head node. So if we are deleting the head node, my new head node should be current head nodes next. And logically, here we are deleting our previous head node and setting the next node to be the head node. So this is how we are logically handling it. Okay. And the data is deleted by that logic. Else, if it is not so, if my data is not matching to the first node, this is what we will be doing. So I'm going further. So now my node to be deleted is any node other than the first node, right? This is the logic we are applying. So we are starting with we can start with the second node or we can start traversing from the first node. That is also fine. Um, but once we will get the data, we have to get the reference of P. So now what we have to do is P dot next will be equal to T dot next. By this logic, what will happen? T will be the node to be deleted. The next node of the T will be linked to the previous node of that T. Okay, so we are creating a connection between the previous node of T and the next node of the T. And that was possible just because of writing this particular operation where we are saying P equal to T. So P will be maintaining every previous node. And after that, we are moving to the next. Okay, so this is how we will be dealing with this particular part. And that's it. The data is deleted. So we can just print it here that data is deleted just to give a response to the user. And if the head node does not exist, that means the list itself is empty. So we can simply print linked list is empty. That's it. So let's call a delete function and see whether the data we are trying to delete is getting deleted. So I'm using the same variable and just asking the user to enter a number to be deleted. And after this, I need to call the delete function. So I'm calling delete function and I'm passing my data into it. After this, to cross check whether my data got deleted, I'll call the traverse function as well. So here I'll say after delete, just to see how the linked list got updated. Let's put some new lines here as our statements are getting printed on the same line. Okay, let's run this and see what we are getting. Let's clear this terminal, run it again. Enter 5 numbers. I'm entering some 5 numbers. The list is getting created. I'm searching for a number 5 and it is saying 5 is present in the list. And let's say the number I'm trying to delete is 3. So it is saying 3 is deleted. And after delete, we can see the changes in our linked list where we are seeing only 1, 2, 4, and 5, and 3 got deleted from my list. So our delete operation is working fine and including all the other operations. So this is all about the simply linked list. I hope you have understood. Any questions you have, you can put it into comments and I will appreciate your feedback. So just share, subscribe and follow my channel. Bye-bye.